All right, so guys, what are these?
Northern Lights.
The aurora borealis. Are you sure it's the aurora borealis?
What the heck is the aurora borealis?
It's an aurora borealis. Okay. Well, here's what we can determine definitely. These are most definitely called auroras. Aurora. And there's actually two forms of aurora, depending on which pole you're sitting at. Our northern lights are called the aurora borealis. And that comes from the term of boreal forest. And a boreal forest is basically like the pine forest. You actually see this right down here. You see those pine trees? That's an example of a boreal forest. And it's kind of neat. It's called, in Russian, it's called the taiga. Not tiger, but taiga. Okay, taiga. And the taiga is literally this band of pine forest that wraps around the entire globe, starting at roughly the 40th or 45th parallel, so 45 degrees north, all the way up to 60 degrees north, and it's just this really thick pine forest, and it stretches around the entire globe on all the continents. So collectively, we call that the borealis, or the boreal forest. So therefore, our northern lights are named after that forest, and we call it the aurora borealis. Now, the one that we see in the southern hemisphere is also called an aurora, but there's one or two continents that are in the southern hemisphere. Antarctica is one. What's the other? Australia. So you have the aurora borealis, which is in the north, and then you have the aurora australis, which is the south. Now, how are these things formed? I'll give you a hint. We're not going to be able to answer that question. But this is another test question right here. This little guy, that's going to be a test question. Explain how the aurora are formed. How are they created? Okay, so that's a really important test question. How are the aurora created? And it goes back to what we talked about earlier with our magnets and the magnetic fields that were created. We will come back to this question later on today. Here's some more wonderful pictures. We're going to see a lot of pictures today. Here's the view of the aurora from outside of Earth. And so you can see where in the original photos it looks like these are on or within the Earth. It looks like they're up in the atmosphere. But what they really are is they're hovering just a little bit beyond our atmosphere. And you can see that here with these shots from the space shuttle. Kind of neat. Be able to see that from outer space. And then with a little bit of satellite help, here's a composite image of the aurora taking place. Now, which aurora is that?
Australis.
Australis. Yeah, that's the aurora australis. You can tell that there's Antarctica. So again, we notice that we typically have these at the poles. And right about the 60-degree line, typically where we're going to start seeing the auroras. On really rare occasions, you can have these become stretched to the point where they are visible. Not so much at our level. I know I have seen them before from Michigan. So, I mean, just a few hundred miles farther north, you can actually see these occasionally, especially in the wintertime. Solar winds, the stronger the solar wind coming in from the sun, the more that these get distorted and pushed down past the poles. So, it's very rare occasions where you'd be able to see those. Pretty neat when you do. So that's our auroras. Really neat interaction. And so all this takes place, right, because of our magnetosphere. And our magnetosphere kind of looks like this little 8-legged spider. In this case, it's a 6-legged spider. Now, the magnetosphere, what is that? What is the magnetosphere?
Obviously, it's the magnetosphere.
We talked about that right at the beginning of class. What is the magnetosphere? Okay. It's just Earth's magnetic field. And just like we modeled at the beginning of class, there's a magnet and then the iron filings that were following the magnetic field on those magnets. We have the same thing on Earth. In fact, each one of these loops, the fields, are collectively called Van Allen belts. Van Halen, Van Allen. So what are the things that make up that magnetosphere? Yeah, do you guys remember any of that from earlier before lunch? Made up of what? What are the things that are flowing through the magnetic field? Electrons. They're exactly. They're just basically charged particles. A lot of ions floating around in our upper atmosphere. And by upper, I mean you're almost to the exosphere at this point. You're so far up, you're just simply kind of hovering around Earth. So a lot of times what happens is our satellites, as far as those are above Earth, they actually do flow through the magnetosphere, and they do occasionally flow through the auroras. So that's our magnetosphere, it's just charged particles. And those charged particles are then just basically traveling along the Van Allen belts, along those magnetic fields. And that's what creates the whole magnetosphere. So it's the charged particles that are flowing along the magnetic fields. So that's all that our magnetosphere is. Just a bunch of charged particles floating around, going from the North Pole to the South Pole, back up, and repeating their process all over again. So we saw this earlier, right? We saw these fields. You can kind of see them here again, right? They're getting a little bit weaker as you come way outside and they come back in. And again, notice that at the North and South Pole, we have these vertical rays that are coming out. And then in between, we have these really thick and round magnetic fields. And that's really important. Because remember, when our solar winds are coming in with the charged particles, they hit those outer edges, and what does that do with those charged particles? Yeah, it kind of diverts the charged particle out away from Earth. So our general setup looks kind of like this. It's very basic. You can see the loops on the sides, and then you have these straight lines that are coming out, and then they make bigger and bigger loops. So again, the farther out you go, again, the more vertical these lines get, and they make bigger and bigger loops. So our magnetosphere goes out quite a ways from the magnet, from the Earth's axis. Okay, it actually goes out very, very far. So this is a typical view, and if I were to kind of diagram them, that's your standard view of the magnetosphere. But then what happens is we have these solar winds. A bunch of more charged particles being emitted by the sun. And what happens is when it comes in contact, we go from the standard image and we get something that looks more like this. So you guys can see here where solar wind's coming in and it's distorting the shape of our magnetosphere. So you can see how it's compressing in the front and elongating in the back. And that's basically how our magnetosphere gets distorted. It's a little shape. Again, that's all because of Solar wind. So again, who can remember what is the solar wind? Yeah, it's just a burst of energy, burst of charged particles. You can almost call it like a stream. Charged particles emitted by the sun.